So now that we know what a thread index and a thread extent is, we will move on to our first hands-on session where we're actually writing some Alpaca code. We will first work on only the kernel, and to do this, I will again point you to the Alpaca workshop slides repository, which is where you will find the code. So whether you're following along in a terminal on Lumi or from the web interface, it's possible to do it either way. Right now, I will demonstrate all of this in a VS Code environment given by Lumi. But again, if you're doing this on a terminal, you can just SSH into Lumi and follow along in your favorite text editor. So for people who are using the web interface, which I highly recommend, you can open a VS Code session, and I will just walk you through some setup steps. So over here, you can see the reservation. So we have reserved some nodes on Lumi for this workshop. Please select.
You don't share the screen.
Oh.
You share only the command.
Thank you for informing me. Sorry about that. Okay. I hope you can see my screen now.
Yes.
Yes. Okay, I will go over this again. So I recommend using the VS Code app provided by Lumi. And once you open it, you see something like this. We have a reservation of some nodes on Lumi, so please select this ENCCS day 1 reservation and the correct project. For the number of CPU cores, I would recommend, if, for example, you want to run examples in parallel on CPU, a number like 4 is probably appropriate. And what I would suggest, using a large number of CPU cores is also possible, but not recommended, as this will eat into the resources of your friends who are also joining the workshop. So please stay below 6. I suggest 4 is completely fine. In terms of memory, 2 gigabytes of memory is enough, and 1 GPU. This is important. Make sure you use 1 GPU, as we will run all the code on GPU as well. For the time, you can really ask for a long reservation. I will do 8 hours. And you don't have to worry about the compiler settings for now. We will load our own. So you can just click launch. This will take a moment while it is trying to start your session. In the meantime, I will point you to some interesting resources. So we have something called the Alpaca cheat sheet. And so you can find it over here. This is the Alpaca documentation, and the cheat sheet is basically a list of commands which are commonly used in Alpaca. So for example, the stuff Mehmet was showing about getting indexes and getting extents is easily found on the cheat sheet. The people in the audience right now should also have a physical copy of the cheat sheet with them. If they don't, please raise your hand and we will get one for you. For the people online, we have the cheat sheet here digitally. Someone will share the link in the Zoom chat right now. So, going back to our interactive session. So, as you can see, it is now running. I have a few cores, I have a node, and I can connect to VS Code. What you have now is a VS Code session running on Lumi. And first off, we will access a terminal over here. On the top left, I hope you can see this, you can open a new terminal. and you can see I am on a node on Lumi. So first of all, I will check where I am. Oh, I am in my home folder. I will go to the source src folder, and I will clone the Alpaca workshop slides repository. So https cloning, copy the link, and simply I will remove it first. You don't have to follow this. Okay, so simply git clone, and this will clone the Alpaca workshop slides repository, which has all of the examples. At any point, if you get stuck, please feel free to send a message in the chat, raise your hand. Okay, now that we have cloned the repository, let's go into it. Alpaca workshop slides. And over here, you can see all the days are listed. Let's go into day 1. And we go to the hello index folder. Maybe I can make it bigger. Okay, I hope this is good. So hello index. Over here, now that you have actually cloned it, I will open this folder inside VS Code. So over here, you can open a folder, and I will choose the Alpaca workshop slides folder and open it. You can trust me, we have vetted the code. I promise we will not do anything bad. So this helps with auto completion and stuff like this. So over here, you can see all of the code that we will go through today. And now we start with hello index. You have a README, which tells you exactly what you need to do in this example, which is go inside the source and edit initialize buffer kernel. So what we are going to do is print the indexes of threads inside a kernel. The kernel launch is already handled. You don't have to worry about any of this. And we will just get the index of a thread and print it. Yes.
Control Alt H. Oh, Control Alt Shift H, and then the Zoom stuff should go away.
Beautiful.
Yes.
Thank you. So, as you can see, we need to get and print the extents and indices of blocks and threads. We already have a printf prepared, which you can uncomment. Oh. Again, sorry about this. I am not good with the German keyboard. So we use a printf and not a standard out, and this is something you might notice. But this is because we are running, this is a kernel that we run on our accelerator. So this might be your CPU, but in most cases, this is probably a GPU. And it is, you might not have access to all standard library functions in a GPU. So we use printf. And what this exercise is asking us to do is to print block index, the thread index in the block, and then calculate the thread index in the grid. So let's start doing this. In the room, does anyone know, or also online, what can you use to really get the block index from Alpaca? So what I would recommend is you look at the cheat sheet, and inside the cheat sheet you will find a function which will tell you how to get the block index in a grid. Can someone tell me what it is called? Come on, let's do it. So I am looking for the block index in the grid. This is a good moment to get familiar with the cheat sheet. For the people online, I will open the cheat sheet and point you to the right place. Yeah. Perfect. Get ID X. So we use get ID X. Oh. Control Alt Shift H. Okay. So using the get IDX function, so how do I get the block index in the grid? What are the parameters I need to provide it? Yes. So get IDX is a very generic function, and the way absolutely. So it should look like this. Sorry. It will be blocks, alpaca grid. So yes, it is the other way around. So first you say, okay, I want to get the index with respect to the whole grid, and I want the index for the blocks. And you provide this with the ACC. So let's discuss the ACC for a short moment. It is something that is passed around in Alpaca everywhere. So all your kernels which are executed hold this object. And when you're executing a kernel, it is passed automatically. You don't have to worry about it. But it is important as context for many of the Alpaca functions. So this is just something you should know. So, okay, this is how I get a block index in the grid. And I will fill it over here. I will say, okay, what, Control Z, Control. So another thing you need to be careful about is that indexing in Alpaca is always in the order of Z, Y, X. So you index the fastest moving direction first. This might be slightly the slowest first and the fastest last. Sorry, thank you so much for the correction. So this might be upsetting to people who are used to XYZ notation, but this is how it is done in Alpaca. The slowest moving index is first, Z, Y, and X. So over here we have a 2D example, and so we are trying to print the block index Y and then X. So this is simply block index in grid 0 and block index in grid 1. So similarly, what we need to do next is calculate the thread index in the block. So please feel free, and I encourage you to do this yourself. Go ahead. I will type slowly just because I type slowly right now, and also so that everyone has time to do this thing on their own and look at the cheat sheet and think about what you actually need.
Here we assume we have a 2D grid.
Yes, here we have a 2D grid, and this example is created for a 2D grid, yes.
I have one question because
Mhm.
the bring function,
Yes.
you are pointing actually 6 values, right? Like it's yx,
Mhm.
yx, right?
Yes.
And no, not 6 values.
8.
but
There are 8, yes.
So from block idx 0 and 1, are you getting 4 and 4? Like how does that bring function
I apologize. Yeah, this is incomplete. So we will add more things currently. So these are only the first 2 that are filled in. So this is only filling in the block index, y index.
Could you shortly repeat always the question from the audience?
Yes. So, okay, I will repeat the question. The question was that we have 8 indexes that we are trying to print. So do these provide all of the 8, or what is happening? So the answer is no, these are only the first 2 indexes, and we have to fill in the rest. So the next step is getting the thread index in the block, which is very similar. Just get IDX.
Look, thread index in the grid first, then the thread index in.
Yes.
It is the you mean thread index in grid, the variable name.
Apologies.
Okay.
Yes. So the next is to get the thread index in the block. First, I got in the whole grid where my block is, and next I will get where my thread is. Just to emphasize, already Mehmet has showed us what the hierarchy looks like, but this is my grid. Over here, I have blocks. So this is a 2D grid. And inside this, I have threads. So, and so on.
Not sure if you could use a whiteboard in Zoom. Okay, then tomorrow's
One can show
Okay,
again.
no, then it's fine.
Maybe I can
Yes,
share
okay.
the drawing.
It should be visible on the camera. So.
It's only half visible, like your face.
Oh no.
Let me share the slide. Where was it?
Yes, we can try to move this up a little.
Perfect.
Awesome. It's
Yeah,
good enough.
yeah, this.
Yes, so as Mehmet is showing, this is how your block, thread, and grid looks like.
Extend slightly, not the extend, but the.
It's okay. I go back to.
Okay.
Oh,
Sorry, I have another question.
yes.
I didn't get quite right what do you mean by calculated thread in grid, because I get the idea of a thread inside a grid, but not calculated thread index in grid.
Yes. So the question is, what is this next step? Calculated thread index in grid. So, okay, we have seen how we can get a block index inside the grid. We've also seen how we can get a thread index inside a block. The next question is, how can I get the thread index inside the whole grid? So obviously you can ask Alpaca for that. We have a helper, but just so that everyone understands how this is working, you can also calculate the thread index inside the grid using just, so for example, if you want to get the thread index for this thread, you need to first say, oh, okay, I go to my block index, I multiply it by the size of a block. And then I add the thread index inside the block to get the total thread index inside the grid. Is this clear? So again, if you had a thread inside this block over here, what you would want to do is get the block index in the grid, multiply it by the size of a block, and then add the thread index in the block. So this is all nice, but how do you get the size of a block? I have not discussed this, have I? I mean, Mehmet did in his presentation. Can someone please help me and tell me what is the Alpaca command to get the size or the extent of a block? Yes. Yes, Brian.
Get work division.
Get work division. So get work division allows you to get how you've divided the work, which includes the extent of a block. So we say get work division, get work div. Sorry about this. Get work div, and I want Alpaca block. So give me the work division of how many threads there are in a block, which is basically the block size. And of course you need to pass it the ACC, as you need to basically everywhere. Okay. So here you are. Let me catch up. So we need to calculate the thread index in the grid. How do you do this? So first you take the block index in the grid. Copy it. You multiply it by the size of the block extent. And then you add the thread index in the block. So this is what you need to do. This gives you the thread index in the grid. Of course, this is tedious if you have to do this for every index. So the good news is that you don't. You can basically say auto.
Could you go back?
Yes.
Code and copy paste it in a comment that this got lost.
Yes. Oh. I will do a. Okay.
Oh, by the way,
Yes.
I think it's required for the output for PDF because it requires to be calculated in a short way also. So you can let it in.
I just wanted to show that you can also do maths. So instead of multiplying block index in grid 0 with block extent 0 and then adding the 0th index and doing this for every index, you can directly multiply the outputs you get from get index and get work div. So I will do this right now, really quickly. Calc thread grid index. And this is equal to simply the block index in the grid multiplied by the block extent plus the thread index in the block. And there you have it. This is the calculated thread index in the grid. Of course, this is something that you might have to do frequently, and there is a helper in Alpaca for that. So now, can someone really quickly tell me how can you get the thread index in the grid just using one command? We already got, for example, the block index in the grid. You can do something very similar and get the thread index in the grid. Exactly, just get IDX and grid and threads. Absolutely correct. So what Klaus said is, you say thread index in grid is get IDX alpaca thread. Oops, sorry, make this mistake. Alpaca block and threads. And over here, yes, this should do it. Let's add these finally. Okay, and this should be the end of our first hands-on. Yes, Rene.
Maybe you can show that for the indices you could also access the indice not by the index domain, the 0 and 1, that you can say dot x and dot y.
Also a very good point. So, as I told you, the indexing happens slowest first, so z, y, x, and it might be confusing to constantly map inside your head that, okay, z is 0, y is 1, x is 2. So what you can do is directly say thread index in grid dot y.
It's a function.
Yes. And thread index in grid dot x. Just to be clear, what we are getting from the get IDX and get workdiv functions is what we call an alpaca vector. It's basically like vectors in science. So an array of 2 in this case, and you can just say access the y element or access the x element from this vector. So there you have it. We are done. What we can now do is,
I have a question.
yes, Klaus?
How do I know that block extent is just a single value and not a vector or something?
So this is something that is lost when you use auto type deduction. So you don't necessarily know this. The way to know this would be to know the work division that you are using. So when I launch this kernel with a 2D work division, you will get a 2D block extent. If you launch this kernel with a 1D work division, you will get a 1D extent.
And with the 2D work division, it will throw an error now.
No, we are currently using a 2D work division, so things should be okay. But this is something that is we will cover later, and you don't have to worry about it right now. So now that we have written it, let's just quickly compile it, see if things work. You go inside the build, say cmake. There's a problem. Yes, because I did not load my environment. So you must run the source command that we have pointed out already. If you can't find it, it's right here in the run example. This is something, every time you create a new environment, you have to load this file again. This loads the important modules and so on. Let it load. Okay. Yes?
Do we also have to add the export we added?
No, you don't. So the question is that we exported alpaca, the path to alpaca. No, we exported the path to alpaca to the CMake prefix, right? Is this what you're asking? Yes, we don't have to do that anymore because we've written these examples to use an alpaca we have set up directly in this environment. So this is something you don't have to worry about. So we are not going to teach you how to configure the CMake for alpaca, but yes, no changes are required from your side currently. So let's select our accelerators. So, okay, this is my sequential accelerator. This is my HIP accelerator. So we use HIP because we have AMD GPUs on Lumi.
If anyone in the audience has problems, please raise your hand and someone will come and help.
We make it. Hopefully things are okay. And let's execute it. So you see a lot of output, really a lot of output. And this is telling you that, hey, we have a lot of threads available. We are using a GPU and yes? Apologies, let's wait.
I do have a question in between. So in the slides that were presented by Mehmet, I just see that one time block is written without an S and another time it's written with S. And the same is, I think, true for threads.
Yes. So
Does it matter or does it not matter?
So the question is, in our code, over here, we can see that blocks is written with an S, whereas on the left-hand side, blocks is without, it's just block. And this is important, and this is a grammar choice because what you're getting is the index of threads inside a block. And so whenever you're referencing things on the left-hand side of get index, you will find that they are singular because you're getting the thread index inside a singular block. So that was the thinking behind the naming. So it is important to have that S at the end.
Personally, I find it confusing and creates some like big blobs of errors, of template errors that are very hard to debug.
So
to understand it's,
this is for example good feedback, and
I don't see the value actually. I mean, we are trying to make it more readable, but at the end, the value is.
I understand, and so the point was that maybe it's better to have a single block instead of having block and blocks. Yes, fair enough.
But rather than getting thread indexes, if we want to access data uniformly. I mean, if you want to map thread index to data index, we have also some additional and easier alternatives in AlphaCard. For example, if you open the vector add example, you will see uniform elements just to access to each thread index uniformly, and it can be used as an alternative, as an easier alternative to this, but yeah, it could be the next next level after learning this.
Sergey.
Two questions. The first one is very simple. How do I execute this file? I missed that.
So yes, just to tell you how to execute it, you go inside the hello index folder. So do you have a terminal open?
So I compiled everything.
Oh, it's compiled, and just /heat equation 2D. This is the name of the file, and you just execute it, it runs. Yes?
I don't know if there was a way to reduce the distance error message when you switch block instead block, so vice versa. I think it could make sense because then people will know how they are, like they are putting in the right order. I see what you did.
Yes.
Sure, we put in the right order as well.
Absolutely.
It's just
So smaller template error messages is hopefully something that is coming soon. We released Alpaca recently, but for the next release, I'm not sure when, we are switching to C++20. The development branch is already on the way. So with that, you will for sure see better error messages. It is.
I'm wondering as well if we could like implement some these template functions with the incorrect arguments and then put some static aspects into them. I don't know, I haven't tried out. This could be another idea, like
Yes.
you could add functions in the code base of Alpaca, but on the other side, the message would probably be much clearer.
Yes,
Yeah,
you're
I
right.
can check if it works.
No, I think theoretically it is absolutely possible to do this with static asserts to get better error messages. But again, with newer C++ versions and switching to concepts, this is probably not going to be required. But you are absolutely right, and the bad error messages is something we also want to get rid of.
At each hands-on session, under the build directory, there is an instruction file which shows how to compile and run the executable. It is under the build directory of each hands-on.
So you can, again, if you have any problems, you can see inside the build directory this build and run file. It has full instructions.
Is it heat equation
Yes.
2D or
Yes.
only heat equation? It should be heat
No, it
equation
should
2D.
So why is it up to 3 dimensions? Why not n dimensions in the indexing?
Maybe Rene is a better person to answer this. The question was, why do we index only a maximum of 3 dimensions? And why don't we have n-dimensional indexing?
Everyone can hear me?
Yes.
Hi, I'm René. I'm the main developer and one of the maintainer of Alpaca, so with other guys together. Yes, the dimensionality of the indice domain is currently limited to 3 domains because we are hardly derived from CUDA, HIP, or CUDA and then HIP was later on coming, and they also limit to 3 dimensions, so we can map directly to the corresponding API functions for HIP or something. without doing some emulations or linearization and then back transformations, what will automatically result into overhead for the modular operations and so on. So that's the current limitation. In principle, the design of Alpaca is not that it should limit, but we are mapping then to the underlying APIs, and that's the reason why we are limited. So, but the limit is for the dimensionality of the indexy domain. So if you work later on with data, we will come to that. You are responsible for your mapping of the indices from the threads to the data. And there you can also work with higher dimensional data containers if you like. And we will also show or mention at least that you can use modern C++ objects like MDSpan for simplifying this handling then with dimensionalities, because we will come to it. Accessing memory can be complicated if you not have only one-dimensional memory.
Thank you.
Awesome. It seems like the first hands-on has gone fairly successfully. So next, I think we have lunch coming up very soon. So we have a 1 hour break for lunch, and then we will keep on diving inside Alpaca and onto more hands-on sessions. So for everyone online, we have a break for 1 hour. Of course, if you have questions, we will be here for a few more minutes. And we will see you 1 hour later at 1:15 Central European time. So a question from the chat, what are we seeing as the output? Is it the layout of the currently used CPU and so on? So exactly, yes. Let me just share my screen again. So what he is referring to is this output. And this is really, for example, I'm currently showing you the output for a given GPU. So you can see we have a variety number of blocks and two-dimensional thread indexes in a block and so on. And for a CPU backend, you would see something similar, but not exactly the same, because for a CPU, you only have one thread in every block. So really, for a thread index in the block, you will only see 0, 0, for example. So it is hardware dependent, but in our current example, we also have a predefined work division. So this is not running for all threads on the GPU. we have artificially limited it. So because we only want to run a smaller number of threads. So yes, it is hardware dependent, but also it is dependent on your actual work division. You could also print this out for a large number of elements if your work division is large enough. So yeah.
Maybe we should phrase it the other way around. We could go maybe in front.
Hi, I'm Julian. I'll later be hosting one of the Pick on GPU sessions on Friday. For now, I just wanted to say maybe we should phrase it the other way around. The range of indices we're actually seeing right now is completely within Alpaca. It is the work division we defined, and the threads and the blocks we're running through is completely defined in Alpaca. But there are limits of what the hardware could do, and if we were to hit those limits, we would get error messages and could not use the work division that we provided to Alpaca.
Thank you.
Maybe we can change that. Oh, I want to see the work division. Don't we print work division? Okay, let me check my code.
Okay, so now we break for lunch. Whenever everyone feels like it or is done running examples, you can.
Could you please say for the online audience when we go on this session?
Yes. So again, for the people joining online, we break for 1 hour and resume at 13:15 Central European time.